What if nothing is truly separate from anything else? There is an experiment that has been performed thousands of times in laboratories across the world with results so consistent and so strange that they have never been seriously disputed. An experiment so simple in its design and so radical in its implications that Richard Feynman, one of the greatest physicists of the 20th century, said it contains the only mystery of quantum mechanics, a result so deeply at odds with our ordinary understanding of reality that Einstein spent the last years of his life refusing to accept it, calling it a sign that quantum mechanics must be incomplete. He called it spooky action at a distance. We call it quantum entanglement, and what it reveals about the nature of reality, about separation, about connection, about the deepest structure of the universe, may be the most unsettling and the most beautiful thing that science has ever discovered. It begins with a simple observation. In quantum mechanics, two particles can become entangled. Not connected by a wire, not linked by a field, not bound by any force that physics has ever identified, but correlated in a way that has no classical explanation, no analogy in ordinary experience, no mechanism that anyone has been able to identify in 3/4 of a century of trying. When two particles are entangled, measuring one of them instantly determines the state of the other, regardless of the distance between them. Not after a delay, not with a signal traveling between them at the speed of light. Instantly, simultaneously, as if the distance between them does not exist, as if they were never truly separate at all, and the distances involved are not small. Entanglement has been demonstrated between particles separated by hundreds of kilometers, by thousands of kilometers, between a satellite in orbit and a ground station on Earth. In every case, the correlation is perfect. In every case, the result on one side is instantly reflected on the other. In every case, the universe behaves as if the two particles, no matter how far apart they are, remain a single system, a single thing. That only appears to be two. Now, the obvious question is whether this is simply a matter of hidden information, whether the particles somehow carry predetermined values that were set at the moment they were created, and measuring one simply reveals what was already decided. Einstein believed something like this must be true. He could not accept that reality was genuinely non-local, that something happening here could instantly affect something happening there, with no signal, no mechanism, no causal connection. But in 1964, a physicist named John Bell proved that this question was not merely philosophical, it was testable. Bell derived a set of mathematical inequalities, now called Bell's inequalities, that any theory based on hidden variables and local realism must satisfy. If the correlations between entangled particles exceeded these limits, then hidden variables could not explain them. Then local realism, the idea that things have definite properties independent of observation, and that nothing can influence anything else faster than light, would be proven wrong. The experiments were done, many times by many different teams, with increasing precision and decreasing loopholes. The results were unambiguous. Bell's inequalities are violated. Local realism is wrong. The universe is not made of things with definite properties existing independently of each other, connected only by signals that travel at the speed of light. At the deepest level of reality, entangled particles are not separate systems that happen to be correlated. They are aspects of a single, unified quantum state that has no location, no boundary, no edge where one ends and the other begins. Separation at this level is not fundamental. It is apparent, and this is where the implications begin to expand far beyond the laboratory. Because if two particles that have interacted can remain entangled across any distance, instantly, without any signal, without any mechanism, then what does that say about the history of the universe? Because everything in the observable universe emerged from the same initial state. Everything that exists was, at the moment of the Big Bang, compressed into a single point of infinite density. Every particle, every atom, every structure that has ever existed was once in direct contact with every other, which means that everything in the universe was once entangled with everything else. An entanglement, once established, does not simply disappear with distance. So the question is not whether the universe is entangled. The question is, how much of that original entanglement persists? And some physicists, following the work of Juan Maldatina and others, have proposed that the answer is all of it. That the fabric of space itself, as we explored in the previous video, is woven from the entanglement structure of the universe. That what we experience as distance and separation is a large-scale, emergent phenomenon built on top of a quantum reality in which nothing was ever truly apart. In this picture, the apparent separateness of things, the fact that you are here and I am there, that this object is distinct from that one, that the boundaries between things feel so solid and obvious, is not a fundamental feature of reality. It is a feature of the scale at which we observe it. Zoom out far enough and you see galaxies. Zoom in far enough and you find that the particles making up everything you see are woven into a web of correlations that spans the entire universe. And the boundary between things, the apparent edge where one ends and another begins, may be something like a horizon, real from one perspective, absent from another. And this has always been what the deepest contemplative traditions have pointed at, not as poetry, not as metaphor, but as a direct recognition of something that careful attention reveals, that the sense of being a separate self, located here, looking out at a world of other things located there, is not the final word on what reality is. That beneath the appearance of separation, something else is present. Something that does not divide. Something that does not end at the boundary of the skin. Something that the particle physicist and the meditating monk are both, in their different languages, approaching from opposite sides. Because if entanglement is real, and it is, then the universe has never been a collection of separate things. It has always been one thing, appearing as many. And if that is true, then the distance between you and everything else, the distance that feels so solid, so obvious, so simply there, may be the universe's way of experiencing itself from the inside, from a particular point of view, from here. And in the next video, we will take everything this series has explored: the self, time, consciousness, quantum reality, the origin of the universe, nothingness, space, light, black holes, entanglement, and ask the question that all of it has been building toward. Not what reality is made of, not where it came from, but why there is something rather than nothing. The deepest question in all of philosophy and physics. The one that has never been answered, and the one that may not need an answer so much as a different kind of looking.